This content is produced by PASS the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A drain can move wastewater and still be wrong if the water seal at the fixture is not protected. That is the central idea I want you to hold through this entire lesson. The trap creates the barrier. The vent protects that barrier. The drain carries the discharge away. If any one of those three jobs is compromised, the rough-in may look complete while the system is already set up. For odor, slow drainage, siphonage, leakage, or failed inspection. For a general B contractor, the practical skill is not designing a complex plumbing system from scratch. It is recognizing whether the work in front of you is coordinated, serviceable, protected, and ready to inspect before walls, floors, or cabinets hide the defects. Start at the fixture trap. A proper trap holds a continuous liquid seal. Under the California Plumbing Code material in this report, that seal must be at least 2 inches deep and no more than 4 inches deep. The water itself is the barrier between the occupied room and the sanitary drainage system. A shallow or missing seal cannot reliably separate the room from the drainage system. A trap that loses its water can allow sewer gas to move back through the fixture opening. That is why I do not look at a trap as a curved fitting that merely catches dropped objects. Its first job in this lesson is protection through a maintained water seal. The shape and the vent connection matter. A P-trap has a horizontal trap arm that continues toward a vented drainage connection. An S-trap drops vertically after the trap in a way that can create self-siphonage. The discharge pulls the trap water along with it, and the fixture can finish draining with little or no protective seal left behind. California materials identify S-traps, bell traps, and crown-vented traps as prohibited configurations. Imagine a contractor checking a bathroom rough-in before inspection. The trap is installed neatly, the pipe is glued, and nothing leaks. But the trap outlet turns downward before a vented horizontal arm can protect it. The problem is not workmanship appearance. The problem is the drainage path. It can behave like a siphon and empty the very seal the trap is supposed to preserve. The reference table on screen puts the core trap and vent distinctions side by side. I want you to remember the simplest connection. The trap blocks the path, and the vent keeps pressure changes from stealing the water out of that trap. A vent introduces atmospheric air into the drainage system so pressure can equalize as wastewater moves. When a large discharge falls through a stack, air pressure changes occur ahead of and behind that moving water. Without adequate venting, the low-pressure area can pull water from nearby traps and reduce or empty the protective seal. The drinking straw comparison is useful as long as I keep it simple. Liquid movement changes when air cannot enter where it is needed. In a DWV system, the vent provides that air path. It is not an optional odor pipe. It is part of the pressure control that protects fixture traps. Open vent pipes must terminate vertically at least 6 inches above the roof surface. The source material also requires at least 10 feet of horizontal separation from an operable window, door, or air intake. Those dimensions are field coordination items. A roofer, framer, plumber, and heating contractor can each do acceptable work individually and still create a conflict if the vent lands beside a window or near an outdoor air intake. Mechanical air admittance valves require caution. The research report notes that local California amendments may restrict or prohibit them, and they cannot simply be treated as a universal replacement for through-the-roof venting. I would verify the local approval and the permitted application before accepting it as the solution. Now follow the wastewater away from the fixture. Horizontal drainage depends on a uniform approved slope. For pipe 3 inches in diameter or smaller, the minimum slope in the source material is 1/4 inch per foot. For pipe 4 inches or larger, a reduced slope of 1/8 inch per foot may be allowed only with approval from the authority having jurisdiction. That approval condition matters. The larger pipe size does not automatically give the crew permission to use the flatter grade. The field check is pipe diameter, actual slope, and required approval together. Suppose a 2-inch branch drain runs 24 feet. At 1/4 inch of fall per foot, the total fall is 6 inches. That is a simple supervision calculation, but it catches real coordination problems. If the framing depth cannot accommodate that fall, the answer is not to flatten the pipe quietly. The route, elevation, framing, or approved design has to be resolved before concealment. Uniform grade matters because the drainage system relies on gravity to move water and carry solids. A line that sags creates a low point where material can collect. A line that rises creates an obstruction to gravity flow. I am not asking you to perform fixture unit sizing or advanced vent calculations here. I am asking you to recognize whether the installed branch drain follows the verified size, route, and grade. The slope and cleanout reference table shows the numbers that are easy to mix up. Small horizontal drains use the 1/4 inch per foot minimum. The 1/8 inch per foot option belongs to pipe 4 inches or larger and still depends on local approval. A drainage system also has to remain serviceable after the building is finished. Cleanouts are capped access points that allow a plumber to enter the line with cleaning equipment. According to the California Plumbing Code material in the report, a cleanout is required at the upper terminal of horizontal drainage piping, at intervals not exceeding 100 feet on a continuous horizontal run, and where aggregate changes in direction exceed 135 degrees. The phrase aggregate change matters. Several turns can add up even when no single fitting looks extreme. The contractor reviewing the line has to consider the combined directional change, not only the last elbow installed. Access is part of compliance. A cleanout serving pipe 2 inches or smaller needs 18 inches of unobstructed clearance in front. A cleanout serving pipe larger than 2 inches needs 24 inches. Those dimensions are not satisfied by a cap that technically exists behind fixed cabinetry, inside a sealed wall, or in a location where service equipment cannot be aligned with the opening. This is one of the shorter cause and effect chains worth remembering. Poor access does not usually stop the system from draining on day one. It turns a future blockage into demolition, delay, and avoidable repair because the design service point cannot actually be used. Fixture protection can also require a backwater valve. The trigger is specific. Fixtures located on a floor elevation lower than the next upstream manhole cover of the public sewer must be protected by an approved backwater valve. The key comparison is elevation. It is not simply whether the room is called a basement, whether the lot slopes, or whether the street looks higher from the driveway. The contractor has to identify the relevant fixture elevation and the next upstream manhole cover elevation. Consider a hypothetical hillside house with a lower level bathroom. If those fixtures sit below the next upstream public sewer manhole cover, a sewer surcharge can seek relief through the lower fixtures. An approved backwater valve acts as a one-way barrier against reverse flow. The supervision issue is to recognize the condition early enough to coordinate an accessible valve and the associated service access before finishes close the area. A backwater valve is not a substitute for ordinary drainage design, and it is not a device to add to every building without analysis. It is protection tied to a defined elevation condition. A closed washer connection has its own dimensions because the discharge enters through a standpipe and trap. The standpipe must extend at least 18 inches and not more than 30 inches above the trap weir. The trap must be roughed in at least 6 inches and not more than 18 inches above the finished floor. The trap weir is the point at the trap outlet that establishes the retained water level. Measuring the standpipe from the floor instead of from the trap weir can produce the wrong result, even when the tape measurement looks familiar. I would verify both relationships separately. Trap to finished floor, then standpipe height above the trap weir. Material transitions deserve the same attention. ABS and PVC are different plastic drainage materials. Standard solvent cement made for only one material is not an acceptable general-purpose bridge between them. The report allows a listed mechanical transition, fitting, or the specified transition solvent cement, identified as ASTM D3138, with the chemical transition limited to a single transition joint per system. the fixture protection reference table groups, the washer standpipe dimensions, backwater valve trigger, vent termination height, and separation from openings. These are separate rules, but they share one supervision habit. Measure from the correct reference point. Plumbing rough-in often collides with framing, and that conflict belongs squarely in general B coordination. For a stud in a load-bearing partition, the source material allows a notch up to 25% of the stud depth and a bored hole up to 40%. Boring may increase to 60% when the stud is doubled, but no more than 2 successive doubled studs may be bored that way. For a non-bearing partition, a single stud may be notched up to 40% or bored up to 60% of its width. The bearing condition changes the allowed cut, so I would not approve a hole based only on how much wood appears to remain. The clean field principle is simple. The plumber needs a root, but the root cannot erase the framing member. When a planned drain does not fit within the permitted boring or notching limits, the solution requires coordination. That may mean changing the route, widening the plumbing wall, using an approved engineered repair, or obtaining direction from the responsible design and inspection authorities. I would not invent a universal repair from a job site habit. Pipe location near the stud face creates a different hazard. When piping is within 1 inch of the exposed framing edge, the report requires a steel nail plate at least 18 gauge thick. The plate protects the hidden pipe from fasteners driven during drywall or finish work. That is a sequencing lesson as much as a plumbing lesson. Nail plates must be installed while the framing is open, verified before insulation or drywall, and left in place where the pipe remains vulnerable. A missing plate may not reveal itself until a screw punctures the concealed pipe, and the leak appears after occupancy. The framing protection table separates bearing wall limits, non-bearing wall limits, doubled stud allowances, and nail plate protection. I put these values together because mixing the categories is the common supervision mistake. Testing is another point where a fast shortcut can create a serious hazard. Plastic DWV piping, including ABS and PVC, must not be tested with compressed air under the California Plumbing Code material in this report. The required approach is hydrostatic testing with water, and the research report identifies a 10-foot head of water for the rough-in test. Compressed air stores energy. If a plastic fitting or solvent-welded joint fails while pressurized with air, the expanding gas can release that energy suddenly and throw broken material outward. Water does not store energy in the same way. A failed water test creates leakage and cleanup, but it does not create the same pressurized gas release. Suppose a subcontractor caps a new plastic drainage system and reaches for an air compressor because it is quicker and cleaner. I would stop that test. Schedule pressure does not change the material restriction. The safe field decision is to use the approved water test and keep people clear while the system is filled and inspected. This is also a documentation point. Before the inspector arrives, I want the test method, test setup, temporary caps, access points, and visible joints ready for review. A system hidden too early or tested by a prohibited method creates rework even if the pipe later appears dry. A productive pre-inspection walk starts at the fixtures and follows the drainage path. I look for a proper trap with a continuous seal and a vented horizontal connection rather than an S-trap. I verify the vent route to the roof and check its relationship to openings and air intakes. I confirm the horizontal pipe size, uniform slope, support, and route. Then I find the cleanouts. I check the upper terminal, long-run spacing, accumulated changes in direction, and the clear working space in front of each access point. I look at lower-level fixtures and compare their elevation with the next upstream manhole cover when a backwater condition may exist. At the laundry, rough-in, I measure the trap height from the finished floor and the standpipe from the trap weir. At material changes, I verify that the transition method is listed and allowed. At every framing penetration, I identify whether the wall is bearing or non-bearing, compare the cut with the applicable limit, and look for nail plates wherever pipe sits close to the framing face. Finally, I confirm that plastic drainage piping is prepared for a water test, not an air test. That sequence catches defects while the responsible trade can still reach the work. It also keeps the inspection focused on visible, measurable conditions instead of explanations after concealment. The memory connection I use is seal, air, grade, access, and protection. Seal means the trap holds water. Air means the vent protects pressure balance. Grade means the drain maintains the approved slope. Access means cleanouts remain usable. Protection means backwater control, framing limits, nail plates, and the correct test method are coordinated before close-in. This is a testable concept based on the published CSLB study outline because plumbing sits within the core trades area for the general B classification. The useful level is field recognition and coordination. Identify the condition, verify the controlling measurement or approval, and correct the defect before it disappears behind finishes. There is an audio practice quiz for this specific episode, so you can check the trap, vent, slope, cleanout, backwater, framing, and testing decisions I covered. It is audio-based. I read each question aloud and you answer by tapping, which is built for people studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so I can help you stay on track through every episode until you get your license.